Question 6 is your generating function question, and we're starting by finding out what the value of k is. So we do that obviously by putting the 1 in, and we know the answer is going to have to be 1. So k ln 2 over 1 equals 1. So k is 1 over ln 2. And you leave that exact, you don't change that because we don't want any decimals here. I'm going to tidy this up as well because I'm going to differentiate it. So we've got 1 over ln 2 times by ln 2 take away the ln of 2 take away t. So I'm just separating the ln's here because then these 2 ln 2's can cancel. So I'm just doing 1 take away 1 over ln 2 times by ln of 2 take away t. So differentiating this, the 1 disappears. Now the ln of 2 take away t, that when you differentiate that gives you 2 take away t all to the power of minus 1. We've got to divide by this minus 1 as well, so that cancels this one here. So you get 1 over ln t times by that. We've also got to differentiate it a second time as well because I'm going to be finding the variance. So times by the power goes down by 1, times by that power in there as well, so it's positive, and ln 2 there. So we've done our differentiating. This one here is going to give us the expected value of x if we put a 1 in it. So if you stick a 1 in there, we're going to get ln 2, 1 over ln 2. Sticking a 1 in there just gives 1 and everything's fine there. The second derivative, g double dashed of 1, sticking a 1 in there, well, that's going to give us 1 over ln 2 as well. Right, so what is the formula for the variance? Just remembering the formula of the variance is, it is the second derivative of 1 plus the first derivative of 1 minus the first derivative of 1 squared. So the expected value of x squared, take away the expected value of x squared. So we've got 1 over ln 2 plus another 1 over ln 2, take away 1 over ln 2 all squared. So that's 2 over ln 2 minus 1 over ln 2 all squared. I think I'll stop there with it. Last part, find out the probability that x is equal to 3. So that involves finding the third derivative because I'm really trying to expand out this thing. So I'm using a Maclaurin expansion. I've already done 2 differentials. So if I just differentiate that again, power, so times by the power goes down by 1. Also times by that as well. So we've got 2 over ln 2, I think there. 2 over ln 2 times by all of that. The probability that x is equal to 3 is equal to g triple dashed of 0, you've run that, divided by 3 factorial. So stick a 0 in there and we get stick a 0 in there and we're going to get, that's 8, 2 over 8, that's a quarter ln 2 divided by 3 factorial, which is 6. So we've got 1 over 24. That should be all at the bottom, shouldn't it? 1 over 24 ln 2, I think. Is this exact or is this a decimal? No, this is just find it out. So tapping that in, 0.0601 at the end there.